Test, test. Test, test. Test. 1, 2, 3. Testing the audio. More testing for the audio. Test, test. We are starting in a couple of minutes. Test. 1, 2, 3. Testing the audio. More testing for the audio. Hello everybody and welcome to this presentation of Cloud HPC in general, but this presentation is also going to show you the new discount for the high use of the Cloud HPC. Thanks to everybody for attending this webinar. This is a new webinar of a series of webinars which is going to last the whole year, so all along the 2022. It's the first webinar of the year, so I wish you Happy New Year, even if we are a little bit late, let's say. Let's start with a couple of brief information about ourselves as a company and also some instruction on the webinar itself and how you can interact with the speaker, so with myself. In fact, it is possible to use the chat available on the right-hand side of the screen. Using that, you can post your questions, make your questions, so interact with me at any time during the presentation. I try to keep an eye on that, so I try to reply to the chat live as the questions are coming by. So no worries about making too many questions. I try to be as present as possible to reply to your questions. Let's start with a very short presentation of the company. The portal we're going to see has been developed by CFD FEA SERVICE. We are an Italian company. Our headquarters is near Verona, in the city in the north of Italy. The company has been founded in 2018, so this is the fourth year of the company itself, and we are working in three main areas: software development, in particular for engineering purposes. We work on the Cloud HPC portal, which is the focus, let's say, of the talk we are going to have today. And obviously, we follow also some consulting engineering activities, both in mechanical engineering applications and civil engineering applications. Today, as we said, we are going to talk about Cloud HPC. This is a website, a portal, which gives access to all of the clients, or every users, to a computing cluster. So in case you are using software which requires high use of hardware resources, you can use a remote cluster in order to run this particular software. So take advantage of remote hardware resources to do that. The main advantages is that you reduce the investments in hardware infrastructure, which for cluster usually are relatively high, depending on the size of the company, can be several dozens of euros or thousands euros up to hundreds of thousands euros. At the same time, relying on external provider allows you not to have downtime, so not to have service interruptions, and to have a continuous hardware upgrade as the technologies, as new technologies are going to come out in IT, which is quite, let's say, a quick development that's happening in the IT. Thanks to the HPC, you can speed up your software, in particular if you're talking about engineering software such as CFD simulation that you're thinking about. They really require high level of hardware resources, and so relying on a big amount of hardware resources can allow you to speed up your CFD simulations, to run more CFD simulation at the same time, or to reduce the CFD simulation time. At the same time, relying on a remote services like ours allows you just to pay for the simulations you're actually running, so you don't have to invest in hardware resources and sometime and somehow, let's say, get a return on your investments through the simulations, but you just pay for the simulations you are actually running on the cloud. And at the same time, you have a system which is always ready and completely tuned to run the software which you have, okay? So you don't have to tune your software, to tune your hardware in order to speed up your simulations. The main feature of our HPC in particular are obviously the scalability, which is probably one of the most important reasons why somebody wants to run simulations on the cloud. Scalability, which can be achieved in two different ways. One is what we call horizontal scalability, so the possibility to execute multiple simulations at the same time. We are exploring this horizontal scalability in another webinar in which we are going to present the DOE, design of experiments of a simple case. And it is also possible to achieve vertical scalability. So one single simulation, which is becoming big because of the mesh size, because of the modelization involved in that simulation, can be sped up using OpenMPI and OpenMP parallelization. I'm not going to talk a lot about these two parallelization methods, but they are both available, and you can run simulations up to 224 virtual CPUs for each simulation. So up to 224 threads or 112 cores in case you want to run a multi-core analysis model. What do I mean by scalability? Well, it would take a whole webinar just to talk about the scalability, but it is important to keep in mind that there is a speed up coefficient, which is the time the hardware requires to get to the results, to the end of the simulations with one single CPU, one single core, or divided by the time the server requires, the hardware requires to get to the results when using n number of cores. This is the speed up of the simulation, okay? The efficiency of the speed up is the speed up divided by the number of cores we are using to run the simulation. We want, in this efficiency, in order to achieve a good scalability, to be as close as possible to 1 or to 100%, depending on how you consider that. This means that we are getting a very good scalability. In general, scalability the speed up tends to grow linearly with the number of cores, number of processors we are using to run the simulations, until we reach a certain point in which there is a deflection between this linear relation, okay? Well, in this point, the efficiency of the scalability tends to be lower. Okay, so basically by getting a good efficiency for the scalability, we want to remain as much as possible into this linear relation between the speed up and the number of processors. In general, it is not possible to define when the point in which we are getting this passage from a linear scalability, a linear relation between the speed up and the number of processors, and let's say we have a distortion of this scalability, as this depends on the mesh size, depends on the modeling involved for your simulation, and obviously depends also on the hardware. Okay, so this we can also help users in order to get the best for their scalability, giving hints, and at the same time we invest as much as possible into choosing the best hardware technologies in order to, let's say, do the best of our part in the scalability. Keep in mind that the scalability is achieved by hardware, but also by the software settings, the simulation settings. So we do our best, but we also, let's say, help users into setting up correctly the software. So that's a good thing we do. All right, I skip a couple of slides in order to get more into the details about the software which are installed on the platform. As we said before, we have two different types of scalability, OpenMP and OpenMPI. Okay, like several software available on the platform can use either OpenMP or OpenMPI or both of them. Like we have Blender, which can use actually both of them. We have Calculix, which can use OpenMP only in terms of scalability. We have Codastar, which can use both OpenMPI and OpenMP. Actually, at the moment, OpenMPI for Codastar is not available on the cluster. At least it is not available for all the versions of Codastar which have been installed. CodeSatur, on the other hand, is able to use just the OpenMP scalability. We have FDS installed on the cluster, which is able to take advantage of both OpenMPI and OpenMP. We have OpenFOAM available, several versions for both from the openfoam.com and openfoam.org. It's worthwhile keeping in mind that we are not an OpenFOAM company, so we propose OpenFOAM installed on the cluster, but we are not developers of OpenFOAM. Anyway, OpenFOAM is able to use OpenMPI scalability. We have ParaView, which is just to visualize data, and we also work with Venture CFD, which is a commercial software which is able to use OpenMPI scalability on the cloud. Beyond the scalability, it's worthwhile keeping in mind that we have machines which allows you to use the OpenMPI only, and machines which allows you to use OpenMP and OpenMPI at the same time. This selection can be made by selecting the RAM, the proper RAM properties for the machines you want to use. We have three type of machines: high CPU, standard, and high MEMB, which allows you to use both multi-thread, so OpenMP, and multi-core, so OpenMPI. So these machines, the first three in this table, are able to use at the same time OpenMP and OpenMPI. So you need to make sure that the software you are running allows you to use both OpenMP and OpenMP at the same time. In case you're using software such as OpenFOAM, which only is able to use multi-core scalability, so we also have the high core instances which only give you access to the multi-core scalability. So it doesn't give you access to the multi-thread scalability. So for OpenFOAM, but also for Codastar and other software, we recommend you to use the high core instances, which are more effective, and it's also, let's say, the most suitable instance type we have for this type of software. So when launching a simulation, please take care of this feature in order also to save money, okay, as we're going to see later. This is another feature we have in our cloud HPC, because beyond the type of instance, you can, the RAM, so the open MPI multi-thread and the open MPI multi-core and the open MP multi-thread, it is both also possible to choose between regular instance and preemptible instances. They are both these type of instances have exactly the same features, except that a regular instance is reserved to you for all the time the simulation requires. So from the beginning until the end of your simulation, your instance will keep running your simulation. Preemptible instances allows you to run the simulations, but it's not reserved. This means that at some point your simulation may be stopped and restarted on a new machine few minutes later. This means that your simulation needs to needs to take into consideration of this, and needs the capability to restart, to save restart file relatively frequently, in order that in case of a restart happens in the system, you're not losing too many seconds of simulated time. Regular instances are compatible with all the software installed on the platform, while preemptible instances currently are compatible with FDS and OpenFOAM only, all the versions of that. At the same time, this difference allows you to get a big discount in pricing. The preemptible instances allows you to get 50% discount in the CPU hours cost, okay? So it's quite a massive discount, which is the reason why most of the time we suggest, in order to get a good cost optimization, to use preemptible instances. For the two software I mentioned before, so FDS and OpenFOAM, these are the settings I suggest you to look at in order to correctly take advantage of preemptible instances. In FDS, you need to set the dump DT restart parameter, and in here you set the seconds, the frequency that you want FDS to write this restart file. In here, just put 300 seconds, but in most simulation, I suggest to use a lower value than that. Instead, in OpenFOAM, into your control dict file, you can set the start from to be latest time, in order to start from the latest time step, and then you use write control, write interval, and purge write to control the frequency that OpenFOAM is using to save a start file. Okay, so use these three commands to do that. So I'm not going into the details about how you can set correctly these parameters, but if you know FDS or OpenFOAM, you are familiar with these, let's say, commands. So I hope you get enough information for that. Among the features which are mostly used by the users, there are two things in particular: the VNC connection, so the remote desktop connection to the simulation which you are running. Thanks to this, you can run ParaView or SmokeView or any other viewers, some such as Salome, Blender, and stuff like that, which allows you to get a runtime feedback of your simulations. Okay, so this is a very good feature we have in place in our platform, and it is available to all the users of the service. At the same time, we give SSH connection. This is probably more suitable for, let's say, advanced users of the platform. Thanks to this, you can enter using a terminal into this instance where your simulations is performed, and you can monitor your simulations, modify commands, or let's say run custom scripts, for instance, in the instance where the simulation is running actually. There are many other features, like we have a whole set of API to integrate the service into your own workflow. We have an easy Linux integration. It is possible to download a tool whose name is Cloud HPC exec, which allows you to get to interact with the platform from your Linux terminal. And obviously there is a support which starts from 9 in the morning until 6 p.m. in the afternoon, European time, so Central European time or Central European summer time, depending on the time zone you are. And this is a support you can access in order to ask questions or to get feedback of your for your running simulation. Okay, I prepared one or two cases in order to launch your simulations, and then we are going to explore actually, let's say, the simulation itself. In here, I'm already logged into the platform. There are 3 pages mainly. The dashboard page, in which you can explore your consumption of the platform. There is a simulation page in which you can see the simulation you have launched, and some of them are going to be running at the moment, but in this particular case, for this account, they are all either completed or they're being stopped. And then there is a storage, which is where we need to upload the file. I prepared some cases to run. The first one is a case for OpenFOAM, for FDS, sorry. So in order to launch the FDS case, we just need to drag and drop the FDS file here in the storage. So we just save, and here it is. We can see the FDS file over here. And we go under the simulation page and we select how many core we want to use, the RAM we want to use, which is the instance type. For FDS, I suggest use the high CPU instance. We select the FDS case we want to run, and then we select for this case FDS 6.7.5, which is the version of FDS suitable for this case. We just press save, and here you are. The simulation is currently running and will be running in 2 seconds. And here it is. The system is going to start the FDS simulation. While the FDS case is going to be launched, we are also going to explore another case, which is the motorbike case. In here, I prepared the case with a mesh and all the settings for this case, like the velocity and everything. Okay. So in here, let me just explore this file in order to see what's happening to the velocity. Well, we just need to make sure we set up correctly this file. So we just set this file to be U. Okay, we are ready to modify this to 0.org. That's okay. We just compress it and we launch it on the cloud. So in order to launch OpenFOAM, I always suggest to create a zip file. Yeah. Which is here. This zip file contains the case file I want to run. Okay. So here in the storage, I just upload this zip file. I press save. I just wait a little bit of time in order for it to be uploaded. Obviously, it might take a few seconds depending on the size of the mesh and depending also on your internet connection, so the speed of your internet connection to the cloud. But as you can see, let's say the overall time is not really really long, but it's in few minutes, in a couple of minutes. I already have my motorbike case over here. So I just launch this case on a 60 machine. This time I pick a high core for OpenFOAM, as we said, since OpenFOAM is just able to use OpenAPI, high core are the most suitable case for that. We choose motorbike and we choose the OpenFOAM version, which for this case is OpenFOAM 8. There it is. FDS is actually running. Okay. So we just refresh the page and there it is. FDS has just started now. You can probably recognize the FDS log as we are used to have it. At runtime, we also get informations about all the output quantities produced by FDS, but obviously, as we said before, it is possible at any time to launch smoke view here from this remote desktop and get a feedback of our running analysis. As you can see, currently I just run 1 second of simulated time, and the file has just reached the bottom of my staircase. Now I run 2.8 seconds, but you can see the file is still at the beginning. But you see, simulation is proceeding independently of what I do. I can monitor that, but simulation will last a couple of some minutes. In here, as you can see, I'm about OpenFOAM is about to launch to be executed. Will take 3 minutes actually to start OpenFOAM, so we just need to be patient a little bit. But as you can see, the 2 simulations are being launched simultaneously at the same time. So no worries about launching multiple simulations at the same time. Just be patient a little bit for the simulations to actually be executed. I'm going to restart the presentation as I don't want to run late, let's say, with your precious time. So we're going to see probably the results of OpenFOAM later on in another presentations. Well, let's talk now about the prices. As we said, it is possible every RAM you are going to use will have a different price. So high CPU machines, which are going to allocate 1 gigabyte of RAM per virtual CPU, costs you 0.08 euro per CPU hour. If you use the preemptible versions, that is 50% less compared to the high CPU regular version. So it's just 4 euro cents per CPU hour. Another instance is going to take a look, worthwhile having a look, is the high core instance, which in here, in here there is a mistake, is 2 gigabytes of RAM per core. That instance costs 10 euro cents per CPU hour, and obviously the preemptible version costs 50% less, so 5 euro cents per CPU hour. This already gives you an overview of the costs of the cloud. Obviously, it's depending on the time you use the cloud, the time your simulation are going to run on the cloud. But already you get an eye on the difference of cost between regular and preemptible. And this is the biggest advantage we are going to show today. So we are introducing progressive discounts. So this means that these are discounts based on the total turnover you are making on the cloud on 1 month. So depending on the total turnover you spend on the cloud on a particular month, you can get from 10% discount up to 30% discounts on the total turnover. Okay, so this discount is calculated on the total use on the cloud HPC services on a month. Okay, depending on how much is the total use of the cloud HPC for that particular month, a discount is calculated. 0% if your monthly consumption is below 400 euros, 10% is if your consumption is between 400 and 1000 euro, 15% if your consumption is between 1000 and 2500 euros, 20% if your consumption is between 2500 and 5000 euros, or 30% is if your consumption is above 5,000 euros. So basically the discount is bigger as your cloud HPC use becomes higher. Okay, so this is, let's say, a discount which is given the more you use the cloud HPC in order to be, let's say, as a prize for companies that are going to use more and more the cloud HPC, in particular on 1 month in particular, okay? Because this is not calculated on your yearly consumption, but just on a month consumption of the cloud HPC, okay? So every month is calculated on the consumption of that particular month. But still this can give you a massive discount on the total consumption you're making, okay? 30% means considering the, for instance, the cost of the high core instance preemptible version, which is 5 euro cent, 30% means that that instance can be paid 3.5 euro cent per core hour. So that is a very cheap price for this particular core hour. Obviously, you need to hit a certain threshold of consumption, let's say, of use of the cloud HPC. That is everything is required to reach that. With this, I'm happy that I have introduced the cloud HPC. So I'm happy for everybody that took part to this presentation. I here report the 3 email addresses and the websites you need to look at in order to register to the cloud HPC. No questions came to the chat during the presentation, so I guess that I've been clear enough, or I hope I've been clear enough for you to get all the informations required to use the portal. So I invite you to visit, obviously, our website and to get in contact with us via email to get all the information you require. I think now we reached the 30 minutes we expected to this webinar to last. So I invite you to follow once again. I thank you all to be part of this webinar, and I wait for you to simulate on Cloud HPC. Thanks to everybody for participating, and see you later. Bye.